Hello my dear students, welcome back to my class. In the series of learning programming in C, in the previous video, we have seen how to perform the product of two matrices. We have seen the logic of performing the product of two matrices. Well, in today's video, we will see the actual program to perform the product of two matrices. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. If you like the video, please click on the like button and share the videos to all your friends. So here is the program to perform the product of two matrices. The half portion of the program I am written here and the remaining I am going to write it afterwards. So here, as usual, we have the main program. We have the declaration of the variables. We have the array A, B, two matrices, and the resultant matrix we are going to store it in P. Some control variables I, J, and for accepting the row and column values of two matrices, we have R1, C1, R2 and C2. Row 1, column 1, row 2, column 2. Right? Then the first message, I'll say enter the order of the matrix. So here I am going to enter the order of the matrix. And this is the program that performs the multiplication of compatible matrices. And I have told you what actually the compatible matrices is. So here the compatible matrices says the number of columns of the first matrix should be equal to the number of rows of the second matrix. Then I can say it is compatible matrices. So in that aspect, we need to accept the rows and columns. So we are going to accept the row value and column value for the first matrix inside R1 and C1. The same way, enter the order of the second matrix, 2% D, that is R2 and C2. Then we are going to read the elements of two matrices. So we all know how to read the elements of the matrices. Those who have any doubts with the reading the elements of the 2D matrix, they can just check out the playlist. I have given the link in the description. You can know how to read the elements of 2D matrix, 2D array. So the matrix elements. So here the first matrix, I say I equal to 0, I less than R1 and J less than C1. Row 1 and column 1. And read the elements into the address of A of Ij. That is first matrix, A. The same way, second matrix. So here we say R2 and C2. Read the elements into B. So here it is A and here it is B. So we will read the elements into two matrices. After reading the elements, then starts the process of performing the product, the multiplication of two matrices. So here I have written the coding of performing the product of two matrices. And here we have the memory representation of two matrices. First matrix A, second matrix B. Assume we have read these elements 1, 2, 3, 4, 5, 6 for the first matrix, which is in the order of 2 cross 3, 2 rows, 3 columns, and matrix 2, that is B, which is in the order of 3 cross 3, that is 3 rows and 3 columns. And here I need to check whether the two matrices order or compatible or same. So here we are performing the product of two compatible matrices, which says the column of the first matrix, the number of columns of the first matrix should be equal to the number of the rows of the second matrix. And why this criteria we need to match, I have explained in the previous video. Please do check out. The link is available in the description. Well, the first thing that what I do is I am going to check the compatibility. That is whether the column of the first matrix, that is C1, columns of the first matrix means C1 equals to the rows of the second matrix. So C1 equals to R2. So we have given the values like this. So 2, that is, this is R1, this is C1, and this is 3 cross 3, this is R2, and this is C2. Row 1 means rows of matrix 1, columns of matrix 1. Rows of matrix 2 and columns of matrix 2. I need to check whether the columns of the first matrix is equal to the rows of the second matrix. Columns of first matrix is 3. right? And rows of the second matrix is 3. Is 3 equal to 3? Yes. Condition is true, means to say the matrices are compatible to do the product. Now, condition evaluated as true. I need to execute this block. The block has been started. Ending, I'll write it at the end of the program. I've written the half portion of the program. How to print the matrix, resultant matrix, we'll see later. First, we'll see the computation part. Now, just observe this coding part. This is what the coding part. We have 2 loops. Totally, when we see, we have 2 loops. But when we get into this block, we have one more loop. So we have outer loop. We have the first inner loop. And here we have the second inner loop. So we have the second inner loop. So we have outer loop, first inner loop and second inner loop. So according to the loop, nested loop concept, the innermost loop has to be executed completely. And then it will go to the next loop. And again that loop has to be executed completely and then to the outer loop. So this flow we know. If you have doubts regarding nested loops, please do check out the videos in the description. I have given the link of all the videos that what we have in the C language list. Please check out the playlist. You can get the idea of nested loop. Well, let me start the loop and I'll write the iterations here. Iterations will be written here now. Now I say I equal to 0, I less than R1. Let me tell you the purpose of all these loops and then I'll start the loop. So here, this outer loop takes care of the number of rows. So I say the first row to be multiplied with the first column of the second matrix. First row of first matrix to be multiplied with the first column of the second matrix. So this outer loop takes care of the number of rows of first matrix. So this outer loop will run twice because you have 2 rows. First row, row 0 and row 1. And when I come to the inner loop, first inner loop, this inner loop takes care of number of columns of the second matrix. So again, so here the condition that what we put, that values you should be very careful. So here outer loop takes care of the number of rows, means it is R1 of first matrix, R1. And the inner loop, first inner loop takes care of the number of columns of the second matrix, means it is C2. That is columns of second matrix, C2. Again you have one more inner loop, second inner loop. This inner loop takes care of one more thing here. See here, when I get into the first row I need to get into every columns. So these columns will be taken care by this second inner loop. That is the columns of the first matrix. So it is C1. So here rows will be taken care by outer loop. Columns of the second matrix will be taken care by the first inner loop. And when I come to the first row, obviously I have to get into every columns. So these number of columns will be taken care by this second inner loop. So I loop, rows, J loop, columns and K loop, again columns of first matrix. I loop takes care of the rows of the first matrix. J loop takes care of the columns of the second matrix. K loop takes care of the columns of the first matrix. This is what the thing with the loops that what we have used in this coding. So let us start with the iterations now. I equal to 0, I less than R1. So I means it is 0. I means it is 0. Let me write here because we have many things to write. I is 0. 0 less than R1. R1 means it is 2. Number of rows of the first matrix. This is what the I loop. Condition true. Get inside. J loop starts. J equal to 0. This is what the J. J equal to 0. J less than columns of second matrix C2. C2 means how much? It is 3. Condition true. 0 less than 3. Get inside. Immediately when I just get into the loop, what happens? I initialize the value P of ij equal to 0. P is my resultant matrix. I say P of ij equal to 0. So that initialization I'll do. I is 0, j is 0 equal to 0. Means the first value, some initial value 0 I'm storing. Then I start with the second inner loop, k equal to 0, k less than C1. K is 0, 0 less than, that is number of columns of the first matrix, means it is 3. 0 less than 3, yes, condition to execute this immediate statement. So here this is what the k loop, and everywhere it is true. So I need to execute this complete line. Look at this line. I say, see, I have to bring this 1, 2, 3 here. Let me write it here. 1, 2, 3. So I need to do 1 into 2 plus 2 into 2 plus 3 into 4. Then I get one value. That value will be stored here. That I need to do now with this loop. So let us see how we are going to get that value. So I say P of ij, that is P of 0, 0 equal to P of ij, means it is 0 plus A of ik. So what is A of ik? I is 0 and k is how much? 0 into B of, look at here, I say A of ik, I representing first row and k representing this k loop. As I said, it is representing the columns of the first matrix. It is 0. So 1 into B of kj. I am going to interchange here. So when I say this to be multiplied with this and again this to be multiplied with the, see, when I bring this the complete row value to the first column, when I come to first column, again I have to get into many rows. The same way, when I come to first row, I have to get into many columns. First row with first column. When I come to first row, I have to get into many columns. When I come to first column, I have to get into many rows. This is what the concept. So I'll interchange this. If you have seen the program of transpose of matrix, then you'll understand how to get into the next row like this. We'll interchange this row and column value. So it becomes kj. So k here, in the first, we are the first iteration, means everything will be 0, right? It is k means 0, j is also 0. So let me take the values now. It is 0 plus A of 0, 0. What is A of 0, 0? It is 1 into B of 0, 0. It is 2. 1 into 2, it is 2 plus 0. The answer is 2. Right? Then, look at here. I am in this innermost loop. As I said, the innermost loop has to be executed completely. Means after executing this statement, the control will be to this inner loop progress, k gets increased. So I need to change the k value. So let me write it here itself. K gets increased. K becomes 1. 1 less than 3? Yes, condition true. Now I say P of 0, 0, ij is the same. Inj 0, 0 equal to P of ij. So now P of ij, the value is changed actually. It is 2 now, right? It is 2. So I make this value as 2 plus A of ik. I is 0. What is k? It is increased. 1. It is increased. Ik into kj. K is 1. So here I am changing, it is 1. So it is A of 0, 1, this value. So 1 into 2 I have done. Next what I need to do? 2 into 2. So it is 0, 1. I have to traverse to the next column of the same row. So it is 0, 1. So it is 2 into this to be multiplied with this. So same column but traverse into next row. So it is B of 1, 0. What is 1, 0? It is 2. So this into this I have done. Now I am doing 2 into 2. 2 into 2. A of 0, 1 into B of 1, 0. 2 into 2 it is 4. 4 plus 2 it is how much? 6. So here I have to change it as 6. Again after executing this inner loop progress, k gets increased. K becomes 2 because I have one more column to proceed with. So here I say P of ij, it is 0, 0 itself. P of ij means it is 6. 6 plus a of, change the values. It is ik. K is how much? K is 2. Into b of kj. K means how much? It is 2. J remains the same. Look at here. Now I need to get different values. 2 into 2 done. Then what I need to do? The same row but next column means 3. That is what A of 02 says. A of 02 means it is 3 into same column next row. It is 4. 3 into 4. That is what B of 20. So 3 into 4 how much? It is 12. 12 plus 6 how much? It is 18. So here I got the value as 18. Hope you have understood this. I am doing 1 into 2 plus 2 into 2 plus 3 into 4. Whole computation I got 18. So that I need to store it in P of ij. P of 00 got 18. Again inner loop progress, K gets increased, but here the innermost loop 3 less than 3. No, condition not true. The innermost loop gets terminated means the control should be to the next level of loop. Means the next loop. Here I have to go to this inner loop. This loop I have to go. So this innermost loop terminated means control to the one more inner loop, that is J loop. K loop done, J loop is still in loop. We are still in the iteration. Now what happens? See, 1 into 2 plus 2 into 2 plus 3 into 4 done. I got the first cell value. But the same row to be multiplied with second column and the same row to be multiplied with third column. Already I have told you, this I loop is taking care of rows and J loop is taking care of number of columns. So I am getting to the next column means J has to take care of it. Right? Now J has to take care of it means first column done, I have to go to the next column. So J gets increased, J becomes 1. P of 0, 1 I am initializing ij. I is 0, J is 1. P of 0, 1 I am initializing it to 0. Now next what I will do after initializing this, K loop starts, K equal to 0, K less than C1. So K loop starts means 0, this is what the K loop. 0 less than C1, C1 means 3, right? K loop representing number of columns of the first matrix. Still we need to have all the values. So we are in the same row. The same row again, first column, second column, third column means 1, 2, 3 to be multiplied with 5, 1, 1 here. That is what we need to do now. So 0 less than 3 condition true. I say P of ij. It is 0, 1. 0, 1 equal to initialize to 0. 0 plus A of, it is I, it is 0 itself. What is K value? It is 0. See the same row, first column to be multiplied with second column now. So it is B of Kj. K is 0, but what is J? It is 1. Because J taking care of the columns of second matrix because I have to come to the second column now. So it is A of 0, 0 which is 1 into B of 0, 1 means it is 5. So what is 1 into 5? It is 5. 5 plus 0 it is 5. So here I got the value as 5. Okay. Then again the second inner loop progress, K gets increased, K becomes 1. 1 less than 3. So remember K is taking care of the columns of the first matrix. 1 less than 3, yes, condition true. Again I say P of ij, that is the same thing, 0, 1 equal to P of ij, the value is changed, it is 5 plus A of ik. I is 0, K has been changed, it is 1. K is 1. 0, 1 into Kj. K is 1, J is 1. So A of 0, 1. So here I am coming to the next column. 0, 1 is 2. 1 into 5 I did. Now 2 into 1 I need to do. B of 1, 1 it is 1. 2 into 1 it is 2. 2 plus 5 it is 7. Okay. Again the second inner loop progress, K gets increased, it becomes 2. Again condition true, get inside. Ij. What is Ij? Ij that is 0, 1 I have changed. So it is 7 plus, let me change all the values so that you don't get confused. Okay, so it is I is 0 itself, the first row itself. K, it is 2, the next column, that is 3 into B of Kj. So K means it is 2, J means it is 1. See here. So I am calculating this value with this B of 2, 1. It is 1. 3 into 1 it is 3. 3 plus 7 it is 10. Again inner loop progress, K gets increased, it is 3. 3 less than 3, no. Condition not satisfied. The inner loop gets terminated. By the time, what is P of 0, 1? P of 0, 1, I just got 10. Right? Then I have to go to the J loop. The first row I computed with first column and second column, but I need to compute with third column also. So J loop has to run once again. Outer loop progress, J gets increased, it becomes 2. 2 less than 3? Yes. Condition 2, get inside. P of Ij, I is 0, J is 2, equal to 0. This one I will make it as 0. Then K loop starts, K equal to 0, K equal to 0, 0 less than 3. Yes, condition true. Now I need to change all the values now. So it is Ij, J is how much? It is 2. P of 0, 2. P of 0, 2 is equal to, it is 0 plus A of I is 0 itself. K, what is K? It is 0 into B of K is 0, J is 2. So this first row again, this value to be multiplied with this. So it is A of 0, 0, it is 1 again. Into B of 0, 2 means it is 1. 1 into 1 it is 1. 1 plus 0 it is 1. So I got 1 here. Intermediate answer. Okay. Again K gets increased. We are still in the loop. 1. Yes, condition true. Ij it is 1 plus A of Ik. I is 0 itself. K is changed to 1. B of Kj. K is 1. J is how much? It is 2. So let me get the values. 0, 1 means the next one. It is 2 into B of 1, 2. This one. It is 1. 2 into 1 it is 2. 2 plus 1 it is 3. So I am going to get here. 2 into 1, 2. 2 plus 1 it is 3. Then again K loop gets increased. K becomes 2. 2 less than 3. Yes, condition true. Because I have one more value now, which is 3. Okay. Now let me change all the values. I'm just erasing all the index values so that you don't get confused here. Okay. So it is Ij, the same thing, 0, 2 I'm going to get, equal to 0, 2, it is 3. Actually, I need to change here. It is 3. 3 plus A of I is 0. What is K? It is 2. 3 into B of K. K means how much? It is 2 and J it is 2. 2, 2. So this into B of A of 0, 2 is 3 into B of 2 of 2. This one. 3. 2 of 2. It is 3. 3 into 3. 3 into 3. It is 9. 9 plus 3. How much? It is 12. Again, inner loop progress, it becomes 3, 3 less than 3. Condition not satisfied. I have to go to the next inner loop, that is J loop. J, see, let me write this value. The value is 12 here. The first row I have calculated. First row with all the 3 columns I have done. When I come to J loop, J gets increased. It becomes 3. 3 less than 3? No, because there are no more columns here. See, we did with the first row all columns. And then first column, second column and third column. There is no one more column. So J also gets terminated.
The remaining calculation will be done in the next part of the video. Stay tuned to my channel. See you in the next video. Till then, take care. Bye-bye.